Hello and welcome back to the 5.1 notes. This is part 3, and we're going to do finish up some of these practice problems. And let's take a look at number 66. And that problem is asking us to take the antiderivative of 2 plus tangent squared theta d theta. Okay. So, but the thing that I want to stress here is that we don't have a rule for tangent squared theta. You have to think about something. You have to ask yourself, the derivative of what gives me tangent squared theta? And nothing does, okay? So we need to manipulate this. We need to change this. So we need to think of our identity. We need to think about what we can sub in for tangent squared theta. You know, you may not know this off the top of your head, but we all know that sine squared theta plus cosine squared theta is equal to 1, okay? And what I want to do is I'm going to divide each of these by cosine squared theta. And what I do here, when I do this, I can kind of expand my my knowledge and be able to write something new, okay? Because when I do that, I get sine squared over cosine squared. Well, that's just going to be tangent squared of theta plus 1 is equal to secant squared theta, okay? I always had trouble memorizing these, but if you remember to start with your Pythagorean identity, then you can easily manipulate this. So let's go ahead and solve for tangent squared theta. Let's subtract 1 from both sides, so then we get that tangent squared theta is equal to secant squared theta minus 1. And let's go ahead and substitute that in for tangent squared theta here. And so I'm going to go ahead and rewrite this as the antiderivative of 2 plus secant squared theta minus 1 d theta. Okay, I can combine my like terms here, and I'm going to get the integral of 1. 2 minus 1 is just 1, so 1 plus secant squared theta d theta. And so as a result, I get that the antiderivative of 1 with respect to theta is just going to be theta. And then the antiderivative of secant squared theta is just tangent theta, okay? And the reason why I know that is because if I take the derivative of tangent theta, I get secant squared theta, okay? And then we have to add in our constant c, okay? But that, folks, is it. That's our antiderivative, okay? Not too terrible, but we have to think about rules. We have to answer that question. The derivative of what would give me this, okay? And if you can't answer that question, you need to manipulate it, and then we need to have actually evaluate it and come up with our antiderivative, okay? Let's take a look at number 70. 70 is a little bit weird. Again, this function here does not look like anything that like the derivative of anything that I know. All right. So what I want to do here is actually kind of manipulate these and rewrite these to see if we can do anything. And what I am going to do is I'm going to kind of create make it a little bit more confusing than it needs to be, but I'm going to go ahead and do the integral. Instead of cosecant theta, I'm going to rewrite this as 1 over sine of theta. And I'm going to divide that by 1 over sine of theta minus sine of theta over 1 d theta. Okay, and the reason why I did that is because if I have these multiple fractions down here, I can actually create, a single fraction in my denominator and then kind of do some more arithmetic and simplify it. So I'm going to go ahead and multiply and get a common denominator down here. I'm going to multiply by sine theta over sine theta. And then this is going to give me the integral of 1 over sine theta divided by 1 minus sine squared theta all over sine of theta d theta, okay? And so let's take a look here. I'm going to do this. I'm going to do the integral of 1 over sine of theta, okay, times the reciprocal of my denominator. Okay, I'm going to multiply by the reciprocal here, and so I get sine of theta divided by 1 minus sine squared theta d theta, and my sine thetas divide out. Okay, so then from there I can rewrite my integral as the integral of 1 over 1 minus sine squared theta, okay, d theta. And to me, that's not something that I still am looking at this and I'm going, okay, I don't really have anything for the antiderivative of this. But let's think about what we've got with that Pythagorean identity again. Let's rewrite this as cosine squared theta plus sine squared theta is equal to 1. If I subtract sine squared theta, I end up getting what's in my denominator. And so I get cosine squared theta is equal to 1 minus sine squared theta. And so I can replace my denominator with cosine squared theta. So I'm going to go ahead and do that. And so then this gives me the integral of 1 over cosine squared theta d theta. And when I have a denominator, or if cosine's in my denominator with a 1 over the top, I can just rewrite that as secant squared theta d theta. Okay, so a lot of work to get to that. However, now I can take the antiderivative, okay? And the antiderivative of secant squared theta is just tangent of theta plus c, and that's my antiderivative, okay? And you can check this by taking the derivative of tangent theta, okay? So now let's go ahead, I'm going to go ahead and stop this video. It's only 7 minutes, so I hope you enjoyed it, and we'll see you soon. Thanks. Bye.